In the mid-90s, data warehousing might have meant using an Oracle database. Today it means a wide variety of things. You could be stitching together a big data pipeline using Kafka, Hadoop, and Spark. You could be using managed tools like BigQuery from Google. You could be doing a lot of things. How did we get from the simple days of Oracle databases to the wealth of options available today? Mark Rittman writes and podcasts about data engineering and data warehousing on his site Drill to Detail. Today we explore the past, present, and future of data warehousing, and we touch on many of the trends that have been explored in recent episodes of Software Engineering Daily. Had a great time talking to Mark, and I think you're going to enjoy it too. Your application sits on layers of dynamic infrastructure and application logic. Datadog brings you monitoring at every part of your cloud-scale application with Datadog APM. Dashboarding, collaboration tools, and alerts let you develop your own workflow for observability and incident response. Datadog integrates seamlessly with all of your apps and systems, from Slack to Amazon Web Services. Your engineering team moves fast, and you can't let integrations slow you down. Go to softwareengineeringdaily.com/Datadog to get started with Datadog and get a free t-shirt. With Datadog's full observability, distributed tracing, and visualization, Datadog is loved and trusted by thousands of enterprises, including Salesforce, PagerDuty, and Zendesk. If you haven't tried Datadog at your company or on your side project, go to softwareengineeringdaily.com/Datadog and get a free t-shirt while supporting Software Engineering Daily. Our deepest thanks to Datadog for being a new sponsor of Software Engineering Daily. Mark Rittman is an independent analyst with MJR Analytics. Mark, welcome to Software Engineering Daily.
Hi then, good to see you.
It's great to have you. And the reason that I wanted to have you on is, as I was telling you before the show, that you have been through several cycles of the space that some people might call data warehousing or big data. You started off with Oracle in the early 90s, and you have worked through to the present day technologies. You've been working with these technologies hands-on, and you write about them a lot. You have a podcast. We'll get into that. And today we have lots of Apache projects like Drill and Spark. We've got a huge variety of cloud options. And I just want to get your scope, because over the past 25 years, there's been so many different products and we've come so far. When you look back over that 25-year period that has been your career in this space, do you see a continuum of data products, like going from Oracle to the present day? Or do you see it more in terms of like clear inflection points where you say, okay, Hadoop happened and this thing dramatically changed, and then NoSQL happened and something dramatically changed, AWS happened, something dramatically changed? Is it a continuum, or is it these clear inflection points?
Good question, Jeff. Well, that's a good one to ask, actually. So let's take a step back and just look at some of the kind of the periods that have been in this area, certainly in my career. So I started off back in about the mid-90s, working, as you say, in what we call data warehousing. So it was a classic IT-driven engagement that we would do. So we would go into a customer, or I would be working at a customer site, and there would be this very, very long and expensive project where we would take data from the various kind of, I suppose, operational systems customers would use, copy it into some form of data store designed for querying, and then use a series of tools or use a series of kind of, analysis techniques on that data, to get some information out. And I guess probably, what hasn't changed over 25 years is that there's always been this thing of taking copies of the data and putting it into somewhere that's more optimized and designed for storage, doing some form of data integration, and then kind of querying it. And so in the old days, it would have been copying it into, say, an Oracle data warehouse or a Sybase data warehouse or Infomix or whatever. So there'd be this kind of copying part. Then there'd be processing the data. So you still get that now, even if it's going into, say, Hadoop and stuff like that. And then preparing it for analysis. So I guess what has been a continuum is this kind of fact that you'd create a separate data store, you'd copy the data in there, prepare it and process it for querying, and then work on it. I guess what is different is the ceremony and the kind of the IT involvement side of it has changed over time. Back in those days, it was, $1 million a month was the kind of billing you'd pay to Oracle to do this sort of thing. These days, it's driven a lot more, I guess, by users and by businesses. And I guess there's less ceremony around a lot of the work now as well. I don't know if you've heard of sort of concepts like schema on read and kind of NoSQL and that sort of thing. So we're still copying data into a separate store, but I guess the ceremony and the process and the expense and the IT kind of driven, the fact that IT have driven it as such has changed a lot over the years, really. But yeah, there's sort of similarities and there's differences, really.
Okay, well, let's go through some of that history and make our way to the present, and then we can get into the future, which will probably be the most exciting part of the conversation. Hadoop. Why was Hadoop so important to data warehousing? If we are looking at things from an inflection, in the history of inflections, what inflections did Hadoop have on the data warehousing space?
Yeah, interesting. Yeah, I think Hadoop has been a real inflection point, really. And there's a couple of characteristics of Hadoop that I think sometimes when you work in this space, it's hard to see. Sometimes, we say in England, we say the wood from the trees, and I guess what is different about Hadoop is two things, really. So first of all, if you look back at the history of data warehousing, there's always been this kind of story about we're going to take copies of all your data and we're going to put it into a single space and we're going to analyze it together. Now that has never in reality been possible to do because of the expense. So to actually create a copy of all your data and put it into one place, and that place you put a copy of data into is Hadoop or a Teradata data warehouse and so on, that you can never afford to do that. Companies can never afford to do that in the end. So every kind of exercise in the space that did take place was kind of piecemeal, really. The other part really was that the ceremony and the process and I suppose the curation that went on with that data to put it into, say, an Oracle data warehouse was so involved and so long-winded that, again, it never happened. Now, what's different about Hadoop is that the kind of the idea with that is that you copy your data into the Hadoop cluster, for example, largely in the state it came from. Okay, so it's a lot simpler and a lot cheaper to load data into the cluster, and it's a lot cheaper as well. So, to store data in a Hadoop cluster is typically, a fraction of the cost of putting it into an Oracle data warehouse or Teradata or whatever. So first of all, it's been possible to actually copy all your data into one place for the first time. Okay. The other thing that's very interesting about Hadoop is if you think about, say, again, Teradata or Oracle or DB2, those old school, as we might say, database engines, the storage and the query engine, the storage and the kind of the way in which you access the data were kind of inextricably linked. So if you stored data in an Oracle database, you had to query it using Oracle SQL or a query engine. With Hadoop, you typically put all the data in one place, but then you apply different query engines to it. So it might be, for example, Presto, or it might be Spark, or it might be Hive, or it might be MapReduce. Okay. So the idea is that you can copy everything into one place. For the first time, it's been economically and time-wise possible to do that. And the second bit is you can apply really any query engine to that data in place. And so that's quite a different approach to traditional data warehousing, where everything was tied together.
Now, the other trend that I think about that took off around the same time as Hadoop was AWS. I think Hadoop was 2005 or 2006, and AWS was basically the same time. What were the ways in which these two burgeoning areas overlapped and affected the evolution of each other?
Yeah, good question. So I think, to be fair, probably the two things happened around the same time, and a lot of consultancies, a lot of kind of people in the industry would often talk about Hadoop and cloud at the same time, but really almost because they were just two things that were happening that were very kind of big. But there wasn't a huge amount of, when you work in consultancy, there's no shame, there's no kind of, you would just kind of mention everything in there as well, and IoT and whatever.
Microservices.
But there were just two things. Microservices and agile and kind of test-driven development and all that. Yeah, we do all that. Yeah, absolutely, we do all that. Yeah, and you and you would hope to move on before kind of like you were called out on it. But I think and I think, to be fair, they were kind of very different. They were very different sort of approaches. So if you think about cloud is almost like time sharing. You would kind of go and we would use Hadoop quite a bit we would use cloud quite a bit in my old company. But you're sharing the resource. So you're going in there and you're renting effectively, instances in the cloud, and you're getting a percentage of the input, you're getting a percentage of the kind of power of that. Whereas with Hadoop, it's like running a parallel server query in the old days of Oracle, for example, in that you'd have multiple boxes that you could actually then query as if they were just one thing. So cloud was almost the kind of the opposite of kind of Hadoop. So in some respects, they were kind of very different. One thing was getting shared access to a common resource. The other one was getting sole access to lots of different sort of boxes, but you had all the power of that. So they were very different, okay, in that respect. And that's why I think it was interesting when people used to kind of, the first iterations of Hadoop would kind of port that into the cloud. And I think would completely miss the point of what Hadoop was about, because you had, no longer did you have sole access to those servers, you were sharing with other people. It completely missed the point. However, I think where the two things have become interesting, and I think Amazon were one of the kind of, funny enough, one of the kind of the leaders in this space, was this whole elastic kind of provisioning side. So now most of the vendors that are doing stuff in the Hadoop space, Oracle, Microsoft with Azure, certainly Amazon. The idea with that is that, you can move compute into the cloud. That is all elastic. It's all abstracted away and so on. So now I think that Hadoop and cloud are inextricably linked, and to the point where really, data warehousing, Hadoop, NoSQL, all of these things, the actual kind of mechanism by which they're kind of like stored, once it moves into the cloud and becomes this elastically provisioned just storage and compute, then I think it's cloud that will be talked about in a few years' time, not Hadoop. Hadoop will just be one internal mechanism that AWS might use to store and process data, but it's all just effectively one elastically provisioned cloud compute and storage resource. That's my theory.
You are building a data-intensive application. Maybe it involves data visualization, a recommendation engine, or multiple data sources. These applications often require data warehousing, glue code, lots of iteration, and lots of frustration. The Exaptive Studio is a rapid application development studio optimized for data projects. It minimizes the code required to build data-rich web applications and maximizes your time spent on your expertise. Go to exaptive.com/sedaily to get a free account today. That's exaptive.com/sedaily. The Exaptive Studio provides a visual environment for using back-end, algorithmic, and front-end components. Use the open source technologies you already use, but without having to modify the code, unless you want to, of course. Access a k-means clustering algorithm without knowing R, or use complex visualizations, even if you don't know D3. Spend your energy on the part that you know well, and less time on the other stuff. Build faster and create better. Go to exaptive.com/sedaily for a free account. Thanks to Exaptive for being a new sponsor of Software Engineering Daily. It's a pleasure to have you on board as a new sponsor. When we're still talking about the earlier days, Hadoop and cloud, it's easy to talk about Cloudera, which was started to vend Hadoop basically because Hadoop was really hard to set up in the early days. And sort of like these enterprises knew they wanted it with good reason, but it was sort of like, let's take something that's like the IBM model perhaps, or I guess a lot of company models at that point, and have a bunch of consultants that you can drop in, and you have specific technology that you can vend. And I think Cloudera did a really great job of accelerating the adoption of Hadoop. What was the impact of Cloudera from your point of view, and how did large enterprises adopt Hadoop around that time?
Yeah, interesting. So I'd say Cloudera are more I'd say interesting. You compared them to IBM and so on. I mean, so again, stepping back a little bit, you mentioned that Hadoop was difficult to install, and so a lot of people who kind of were playing around with Hadoop and were trying to understand Hadoop and MapReduce and so on, got caught up in downloading the open source project. Then trying to write their own kind of routines in MapReduce and Java and so on, and that reminded me completely of the original days of Linux. So I don't know how old you are, Jeff, but certainly I remember back in the kind of 90s downloading Slackware and various kind of versions of kind of Linux. And, you would arrive at my house in a series of kind of CDs or floppy disks, or you would download the Linux distribution from the Apache site and this sort of thing. And you would sit there and you would kind of compile your own kernel, and you would kind of sit there and we were using very early versions of a lot of the window managers and so on. So really what came along then that popularized Linux was Red Hat, for example, was SUSE, was Ubuntu in time and so on. So I see, and there really was only one kind of like commercial success out of that, which was Red Hat, and their model was support. So they would support kind of like Linux at that time. And so Cloudera, alongside Hortonworks, particularly, were the two companies that were just like kind of, to my mind, they were like SUSE and kind of Red Hat in a way. And to my mind, kind of like, Cloudera like Red Hat and typically there's a market leader, and that was Red Hat. And there's then typically the kind of followers, and in every market there's like that. So in the same way that I think the Linux market had SUSE, I see that as being Hortonworks, almost the kind of the holier than thou, we're open source, more open source than anybody else kind of thing. So you also get, you now get, so you've also got, vendors like say MapR and so on who've taken quite a kind of commercial approach to doing it there really. But back to your question, what does Cloudera bring? Cloudera effectively kind of not consumerized Hadoop, but they certainly made it possible to download, and work with this at home, work with it in the office and so on there. They wrapped a kind of a support contract around it, but they also weren't they commercialized it as well. And I've had quite a few dealings with Cloudera in my time, and in some respects they're more like Oracle than Oracle are. They're certainly aware that there's a kind of like a business model to be had there really. So I think Cloudera made Hadoop kind of accessible to people who didn't want to kind of be downloading disks and so on else. But I'm not necessarily sure. It's interesting you said about they were the name Cloudera suggests cloud. But I'm not sure what their future is going to be in the cloud, really, interestingly.
Well, okay. Well, we should discuss that a little bit later on, because I want to get eventually to a discussion of AWS and GCE, and I think those are the really exciting areas to unpack. But to give us more of a foundation, little more of a historical foundation, around this time that we're touching on, this Cloudera, early Hadoop days, there were these things like HBase and Hive and kind of this Hadoop ecosystem started to develop, and then there were things like Storm, and Storm started to get popular. I think I remember hearing in your podcast, it's Drill to Detail, right? That's the name of the podcast? Yes. So I think I remember hearing that in that podcast, either it was you or the guest who said that Storm was in some ways sort of before its time, and I guess give us a picture for when did we start to get from the days where we were just doing kind of batch Hadoop stuff and we were looking at better ways of doing batch Hadoop to the more modern systems like Storm. Well, Storm, like we said, maybe that was before its time, maybe systems like Spark, but these systems where you get more of a real-time processing thing. How did we make that jump as a community from the batch to the more streaming world?
Okay. So a bit of context there. It was the podcast episode I recorded with Alex Olivier from Qubit, a company I'm doing some work for at the moment. Actually, I'm in there doing some PM work for them, and so we were talking there about their evolution from doing batch uploads to now processing I think it's 100,000 events per second, going into their Hadoop, actually going into their Google Cloud, kind of environment and so on. So to answer your question, how do we get from batch to real time? Well, Hadoop has always really been about real time. So if you think about, very early, use cases and examples for Hadoop, they were always, typically they were almost always working as a real time system. So you'd be streaming in, maybe using kind of, I'm trying to think of the words here. Actually, you would be streaming in data into say MapReduce. You would be then processing that in real time. You'd be doing various things there. So Hadoop would always be coming from a kind of real time perspective. But the question was, how could we effectively kind of process that data so we can land it in real time? Using like sort of Flume or using kind of various technologies there. How could we process it in time? And so that has been a problem that has been trying to solve for a long time, really. And coming from the data warehouse end of it, real time has always been the hardest thing you can do. It's the point where, you always start with batch there. And actually, real time was the hardest thing to get to. That I guess if you kind of pick up the point at which, to my mind, where data warehousing effectively becomes yesterday's technology is the nearer you get to real time and the nearer you get to kind of large scale. That is where, old school data warehousing and old school relational databases with their traditional kind of like, rollback segments and kind of, transaction support and that sort of thing. They can't deal with that. So where we are now is that almost every system that I architect now or I would build or be involved in is always going to be real time. Okay, part of it is because people want to have response to things quickly. Part of it is because if you don't deal with it in real time, you're never going to get around to processing all the data. Okay, just you've got to process it as it happens to even have any chance of kind of understanding what's going on. But things like Storm, there's been a lot of kind of attempts to solve this problem, that, because of just a better way of doing it has come along, has actually been, it's been sort of superseded. So Storm was a good example there of, there was nothing wrong with Storm, but then Spark Streaming came along, for example. And then because of the nature of open source technology, that there is no kind of central PM that's controlling all this. There's no central kind of planning that is saying, well, we're now going to do Storm for a while, we're going to do this. If something better comes along, it just gets picked up and it's used. And so the example that we talked about in the podcast was, they've moved to kind of to cloud data flow. They've moved to PubSub and so on. It's just because there is no license investment people have made, because there is no real kind of like, sunk cost in going down this route. If something else comes along that's better, you can just use it. And that contrasts massively with my old world of, say, Oracle, where, you might spend $1 million on licenses for a data integration tool and a database and so on. And even when there's far better things to solve the problem with now, you've spent all this money, you've trained up people and all that kind of stuff that you can't shift from it. So a lot of it is interesting in that you can just adopt whatever is new that's come along, but it does mean you've got to be on your toes a little bit as well. And I think that going back to maybe the title of your podcast, I think there's a much greater need now to be a software engineer when working with this sort of technology, rather than perhaps the point and click people that used to be working with kind of graphical tools and relational databases.
Although, as we get to the conversation around Google, it does seem like Google is trying to at least make it an option to work within a high-level dashboard-like environment where you can be a point-and-click data scientist or data engineer because of, like you said, going towards a cloud computing model where you're not thinking of things in terms of Hadoop. Perhaps this is the serverless discussion where you're not thinking in terms of servers, you're not thinking in terms of logging into a console. You're just on like a dashboard through a web browser, and you're doing all your data warehousing operations through that.
Well, yes and no. I mean, let's take the two things there. So first of all, so we'll get on to Amazon in a second. But looking at Google Cloud Platform now, yes, you've got BigQuery, which it takes away all of the complexity around managing things like rollback segments and managing things like backups and instance tuning and all that kind of stuff you used to do, in a data warehouse environment. It also takes away all the work you used to do in terms of data modeling and writing ETL routines and so on there. But Google Cloud Platform in particular is, once you get into using things like PubSub or Cloud Data Flow, it's coding. The coding you do is not that difficult, not that different to what you do with, say, Spark Streaming and so on. Yeah, there are technologies within, say, Cloudera. You've got things like morphlines and stuff like that, and Kudu and Kafka, which are a bit more about configuration rather than coding. But I would say that an individual developer is a lot more productive than they used to be. But I'd say the skills required, I think there'll be a whole bunch of people left behind at this rate who are more, I suppose, from the system integrator kind of world, who are more about pointing and clicking and doing things like that. That is not the world, there is not the equivalent of an Informatica, for example, that you would use with Google Cloud Platform. Now, where Amazon gets interest, so that's the interesting thing. And there are tools like, say, for example, Oracle Data Integrator that you can use with kind of Hadoop, but the cost of those is massive compared to what you're used to paying. So, Hadoop to use, you can start with a few dollars, if you're using it in the cloud and so on. But the way tools like ODI and Informatica are licensed, you're talking like $1 million before you do anything really. And so that is just ridiculous in that kind of world. But where it gets interesting in the Amazon world is that you've got, I don't know if you must have heard of it, called Amazon Glue. It's the new thing that's coming along, which is about kind of automatically, introspecting, your kind of source systems, mapping those into the target cloud environment, automatically working out the kind of data transformation routines. I mean, it sounds too good to be true. I haven't heard of this.
Huh.
Amazon Glue. No, I mean, it sounds like if your business is system integrating, you go and shoot yourself if you heard this, because it sounds like it would do your work of kind of 20 people, but because it's Amazon and because I've got loads of Echoes at home, I know how well they work. That's interesting. But then with Amazon has a very different approach to how you do kind of like, I suppose, data and analytics on their platform. So they have a tool for everything. You've got Amazon Aurora, you've got Amazon Athena, you've got all these different kind of things there. And so it's a very modular approach. But again, you've got to know what you're doing as well. So what you're doing, it abstracts away a lot of the complexity of certain things. Their business is to make the things that are complements of that as cheap as possible. But you've got your own new set of skills you have to have. To understand an Amazon, which of these various different compute engines would you use? EMR is obviously in there, Elastic MapReduce, but that again is probably a bit of a distraction and probably yesterday's technology. And then you've got things like Glue, which if it comes to if it turns into what they say it's going to be, could well be, the end of 1,000 people's jobs, because it sounds like it does the work of an ETL department in one tool. So it's very interesting.
You touched on something that's pretty profound there, I think, in the analogy between, maybe you didn't mean it this way, but the analogy between the Alexa or the Amazon Echo ecosystem and the AWS ecosystem, where it almost defies any previous analogy, because it's not exactly an open environment, it's not exactly a closed environment. It's like just this environment where Amazon provides a world that is very easy to play in, very fun to play in, but it's not completely open. At least that's my understanding of the Amazon skills. Like, it's very easy to write Alexa skills, and then you're integrated with Google, or you're integrated with Amazon, and it sounds like the Glue perhaps is similar to that, where it makes I don't know. Could you describe that Glue thing in more detail? Because I don't quite understand what you were talking about there.
Well, okay, so Glue actually, interestingly, is, I mean, I've got Amazon Echoes at home. I've got 5 Dots and 2 Echoes in the house, and a Google Home and everything else. It's ridiculous what I've got.
Oh wow!
And so it is like but so I'm quite into all that technology, as you can imagine. And so I think there's some interesting similarities there. So the thing about the Alexa service is that it abstracts away a lot of the complexity about certain things, but it also I'm trying to think of the analogy here, really. It kind of, the Amazon environment and the Amazon ecosystem as a developer is not particularly directed and kind of controlled and constrained. Okay.
But it's not open source.
No, it's not open source, but you can go and write, I could go and write an Amazon Alexa skill tomorrow, about, facts about your podcast. and I could publish it on there, and it would be available 2 or 3 days from now. Okay, so so there's no kind of in a way it's almost more like the Android Android Play marketplace than say the iOS App Store. So Amazon's approach is very much, we are going to throw a whole bunch of things out there. Where it's like a sort of a set of Lego bricks that you can go and do what you want with. There's no particular kind of building first for Amazon the retail store. So Amazon the retail store is the sort of primary and first customer for a lot of these things. But there's no particular building it for Amazon's own use and then making it available externally. So there's no particular kind of planning there. I think, well, obviously there is planning because they're not stupid, but there's no overriding, this is the direction we're going to take. We are now going to say, this is how we do compute on the cloud and so on. There's a whole bunch of services out there, of which, Amazon, the retail store, is probably the kind of primary customer. Whereas with Google, and I would say, particularly Google, I'd say, the technologies they build around big data are built first and foremost for Google's own use internally. So, BigQuery was originally, I think the name now actually. There's Dremel, that was it. So BigQuery was originally Dremel. That was an internal service at Google. It's now been made available externally, which is fantastic because you can effectively bring in the entire compute resource of Google to do your work for you. But, if that's not how you want to do it, well, then you can just take a walk because, this is the only way you can do it. There's only one compute engine you can use. There's only one storage engine you can use, and that's it. And so, in some respects, that's good because you know what you're doing. The other one, the Amazon one, is much more of a modular approach and says, here's all these services. Just you go and enjoy yourself. You go and do what you want to do with these. Really, we're not going to impose any control over it. We're just going to say, here's the APIs, here's the interfaces, and so on. There, you go and do it. And I don't know which is the best way of doing it. What I do know is that I think that those vendors that aren't as good as Google at consumerizing this, and those that aren't as good as Amazon at modularizing this, I wonder what their kind of like their selling point is going to be.
It's also an opportunistic thing because Amazon was first to market, so they've been letting a thousand flowers bloom for a while now, and they've got all kinds of customers on all kinds of different systems. It's not like they can roll back and say, this is the way that we're going to do things. Whereas Google has, in some sense, a last mover advantage, even though they probably didn't plan. In fact, I know they didn't plan it this way. They didn't realize how big cloud was going to be, and then it became really big. Or actually, arguably, Google was earlier to market with the App Engine, and the App Engine did things too opinionatedly, and then so Amazon moved in with the less opinionated approach, had massive success, and then now the Google opinionated approach almost makes an equal amount of sense at this point because Google has been watching somewhat from the sidelines and saying, this thing might make the most sense. This thing might make the most sense. They can say things like, okay, look, we've been managing our data centers for a long time with essentially Kubernetes, with the internal version of Kubernetes with Borg. And they can say Kubernetes is the way that you want to do it. If you want to be on the Google platform and you want to manage your infrastructure, this is the way to do it. With machine learning, they can say, this is the way to do it. This is how we do it internally. We're externalizing this service. This is the way to do it. And so it is this interesting contrast in how the different companies have evolved, and you can play in either environment. And it's funny because in this, if we're drawing the iOS versus Android analogy, Google is the iOS approach in the analog.
It is, and I don't think. I think the other interesting angle to it is how they treat their customers and developers as well. And so I think Google is a kind of a very good consumer company, B2C company. I think certainly B2B is interesting. I think that there's not been perceived to be a huge amount of kind of love and kind of I think the way they deal with their customers on a B2B basis. I mean, certainly we've been a big customer of their kind of Google Apps package for many, many years. And I just dread to think the day that ever it went wrong because who would you contact and so on. But I think Google's saving grace is their engineering is just fantastic.
Right.
And the environment is a pleasure to work with as well. So, yes. I generally develop in kind of Google Cloud platform now. I use it at home for the stuff that I do with all my kind of home IoT stuff. And it's a pleasure to use. And going back to my point before, I think that if you're a vendor that is trying to be more prescriptive over how you do things, but your engineering isn't as good. Let's take, for example, Oracle as an example there. Or let's imagine that you are trying to be more modular and trying to say, well, actually, like you say, let 1,000 flowers bloom, but you're not as good at doing that, or you haven't got the sort of scale advantages. So I'm thinking like, Azure here or stuff like that. Then it's interesting to understand, well, what is your kind of appeal then, really? I think you're either going to be, either way, Amazon is the Microsoft, really, of the cloud era. They're the ones that say, here is a platform, off you go, there we go. Whereas maybe sort of Google is the Apple of this kind of period. And so you make your choice, really, which one you go with. But if you're not as good as Microsoft in terms of being a platform play, or you're not as kind of cool or not as kind of good experience as Apple, like say B used to be or whatever, then where are you going to be?
I gotta ask you about the Google Home versus Alexa or Amazon Echo experience. This is totally unrelated to data warehousing, but I think anybody listening to this podcast will be interested in your thoughts. I have a Google Home. I tried out Amazon Echo before I saw Google Home announced, and I returned it because I figured Google Home would do a better job. And I think something I've realized is that I miss aspects about the Echo, but I still love the Google Home, and I kind of want to get Alexa again. I kind of want to have both of them, just because these things are, for people who are listening, if you have a software engineer salary and you haven't gotten one of these devices, you should get it because they're just incredible. But what I really want to ask you is, what have you learned from having both of them? What are the query types that Google is really good at, and what is Amazon particularly good at?
Well, I'm a bit of an expert in this, as I've got all these things now, and I sneak them into the house with the wife not really. I sneak them into the house without the wife realising what they are, because I have spent quite a lot of money on these things over time. And I think the Google Home looks like an air freshener. So I managed to kind of get away with that for a couple of weeks before the kids kind of realised what it was, and then they saw the video on YouTube where you can get the Google Home to speak to the Alexa, and then the Alexa speaks to the Google Home, and they get in this kind of loop. And so they found that, and they thought that was hilarious. So I was busted at that point when that happened. But so Alexa, as I say, Alexa is like the Windows. It's like Windows 98. It just. I know it sounds funny to say this now, but it. Oh! Sorry, that's my Alexa. That's my
Don't
Alexa.
order a dollhouse.
I've got one. I brought one with me. I brought one of my dots over with me. It's in the hotel room in San Francisco. But it heard me mention it itself. It's just it just replied to me across the room. So that's funny, actually. I just, as an aside, I work with someone called Alexa, and I was thinking, if I was her, you wouldn't be able to get these things, would you? Because you'd always be setting it off. But anyway, so the thing with the Alexa is that it's got it's so easy to add skills. So if you're one of those people that's got these kind of home devices, or you've got a Nest, or you've got all these kind of things there, you could almost guarantee that there'll be an integration in with the Alexa. And if not, you could write it yourself. And I'm writing integrations myself at the moment to control various things and so on. I think the Google Home one has got is better at understanding language. So I think where Amazon have done well with the Alexa is they've got a fairly limited vocabulary, and you have to be quite careful what you say. So it's fairly common in our house, because every room in the house has got hue lights in there, for example. So there's about 30 hue lights in the house, and so it kind of keeps getting those wrong, which ones you're talking about and which rooms and so on. Whereas Google Home is a lot better at understanding the intent of what you're saying and so on. And what Google Home is also better for is things like what would be a classic kind of Google search. So, if you say, okay, Google, what's the capital of kind of China or whatever, it would give you an answer, whereas Alexa doesn't do that really. So I personally, it's interesting, the Google Home has almost got me to the point of swapping all my iPhone stuff to using the Pixel, the Google Pixel, because Google Assistant is so good.
It's incredible.
I would say that it's enough of a thing that tips you over. So everything, I've got a Mac, I've got an iPhone, all that kind of stuff, and Siri is just a joke in this area. the classic thing, it is where you say to your phone, switch on my kettle, and it understands you. Say to your iMac, say that, and it doesn't understand you, because it's all very much there. But I'd say the Google Home is so good at understanding the intent of what you're trying to say that it almost in itself tipped me over to the kind of Google world from someone who has got Apple kind of like, written through him like a stick of rock. So I'd say that it's better, but there's more integrations. It's classic Mac versus Windows. Google Home is better, but there's more integrations with the Alexa.
When you are continuously deploying software, you need to know how your code changes affect user traffic around the world. Apica System helps companies with their end-user experience, focusing on availability and performance. Test, monitor, and optimize your applications with Apica System. With Apica Zebra Tester, Apica Load Test, and Apica Synthetic, you can ensure that your apps and APIs work for all your users at any time around the world. Apica Zebra Tester provides local load testing for individuals, small teams, and enterprise DevOps teams to get started quickly and scale load testing as your needs evolve. Apica Load Test ensures that your app can serve traffic even under high load. Apica Synthetic sends traffic to your website and your API endpoints from more than 80 different countries, ensuring wide coverage. Right now, you can go to softwareengineeringdaily.com/Apica for a webinar about the real ROI of API testing. You can also find past webinars, such as how to optimize websites for fast load time. Go to softwareengineeringdaily.com/Apica to find the latest webinars on load testing and lots of other topics, and check out Apica System for testing, monitoring, and optimization. Thanks again to Apica for being a sponsor of Software Engineering Daily. Especially if you're an Amazon power user and you order all these stuff from Amazon, the ease of ordering is great. But anyway, I don't want the listeners to accuse me of being a gadget podcast, so because there's so many of those. So let's talk about machine learning, because
yes,
this machine learning in 2017 seems to be pushing. If there's a bellwether for where quote unquote data warehousing is going to go, it's like the problems of machine learning. And I think there is this I did this weird show about the pancake stack. I shouldn't say it's weird. This is where people are going, but the pancake stack is basically, how do you get online machine learning? Basically, how do you get to the point where a single training example can easily propagate through and add to your machine learning model, whereas in the current day, a lot of systems are just batch processing a bunch of training examples. You wait until you got 50,000 training examples, and then you do your nightly batch processing job of machine learning. I guess in your travels, am I accurately portraying the way that, is this one of the canonical problems that you see in machine learning? And I guess more broadly, how is machine learning affecting the data warehousing space?
Okay, so first of all, machine learning is, God, in every, I don't know how long you've been doing this, but certainly for me, at every point, there's something which starts to kind of grate in the background that is just trotted out at every kind of every client meeting, or every kind of, it was agile development, it was test-driven development, it was now it's machine learning. Before it was kind of OLAP, or it was in-memory computing and so on. And all of these things are absolutely fantastic. And my career has been built off of faddy things that customers kind of want. And you go in there, yeah, we'll do this. And yes, we'll do in-memory, we'll do that. And they're fantastic. And they're what keeps you interested day in, day out. But the reality is they're just one part of kind of a solution, really. And machine learning it's the kind of thing that you add into every conversation you have, or if you're building a product, you say, and it's got machine learning and so on. And come on, we all know that actually, it could well be things like just stats, or it could be things like linear regression, or it could be, but it's a thing you put in there, and it would have been, VR, or it's I don't know. I maybe sound slightly cynical, but I'm working some contract work for a company at the moment where we're massively building machine learning stuff out, and I'm at the coalface of doing this, and I work with analytics, I work with machine learning, I work with data warehousing, and I'd say that machine learning it's like macro and micro. If you think about, let's imagine you're building out a platform that is going to do. Let's look at the example I'm doing at the moment. So I'm working for a startup at the moment where they take in huge amounts of kind of consumer data. It comes in via links through to websites and so on. It takes in now 100,000 events every kind of second, goes into this massive kind of data lake. And the headline is, we do machine learning on this platform. And we do, but it's one small part of what you might consider to be analytics. And so if you're trying to do things like, maybe things like predictive models, or that's sort of machine learning, but it's sort of also really linear regression, that sort of thing. If we're talking about doing things like purchase recommendations, so product recommendations and so on, that's part of it as well. But actually, there's a much bigger picture there about, or how do we sort of like predict forward? How do we kind of model things like different approaches you could take in a sort of product launch and so on there? I mean, I think that machine learning is important, and I think there's some very kind of clever things coming along with it, but it's never it's like a very lucky idiot that you're kind of with, really, in some respects, in that it's very good at telling you this is where an opportunity is, or this is where we think things might go. It has no idea half the time of kind of why that outcome was kind of like predicted. It's like having a very lucky friend who has got no idea why he keeps kind of rolling double sixes, and in a way you want to go to the casino with this friend because you're going to walk away rich at the end of it. But let's face it, he had no idea why he was rolling double sixes. And so that's machine learning in my respects. And I'd say that also, it's also worth having a friend who sort of understands the general kind of odds that you've got in the casino and that sort of thing. And so I'm trying to say, it's good, but it's not a kind of a silver bullet for everything, really.
Absolutely. But to some degree, if you get a deep learning system, then you can just configure it such that you throw more and more data at it, and your friend gets luckier and luckier as time goes on.
Yes.
And that is in some ways quite promising, because it's, all right, we don't have to, we will build more sophisticated systems. We will get the deep learning systems to be more sophisticated. But it is this nice trend that we can see that it's going to buoy us for some period into the future of progress, in terms of where, as long as we can feed the data monster, it's going to get bigger and hungrier and more helpful. And my question to you is sort of, where does that lead the data warehousing systems that we have today? Do they need to change, or are they already well suited enough to serve this future that we're careening towards?
Well, it's interesting. Again, stretching this analogy even further than it should be. I think your deep learning is like a friend of yours who goes to the casino with you, who can also count the cards as well. So he's going in there, and he's now worked out how to count the cards. So he's sitting there and he's kind of keeping an eye on the cards that are going in. And not only does he roll threes all the time, but he can count the cards that are going through. Now, at some point, he's either going to be found out, or you'll be a billionaire, but he's never going to end up running the casino. And I think in a way, data warehousing there is taking a step back and saying, right, we've got this kind of scam going on. We've got this thing going on where we can count the cards, and we can throw the sixes and all that kind of stuff. But in a way, what data warehousing is saying, well, how did we work out in the first place that we should be going to this casino, and we should have this idea? Okay. So scoping out which of the casinos to go for, that's kind of where, at a very kind of almost macro level, working out, well, which of the casinos and which of the card games should we be focusing on? And also, how do we reinvest this money we're making on this card counting, double sixes rolling thing? How can we reinvest that money to kind of like to maybe buy our own casino, and then ban card counting, and then ban kind of like, craps and stuff and that sort of thing? Machine learning is good. It's focusing on a particular area, and it's really kind of getting to the bottom of how to do this efficiently. And it's learning and all that kind of stuff here, but it's focusing on one thing only. And I think data warehousing and the discipline of gathering data together and making it. Don't forget, when you do machine learning on data, there's huge amounts of work that's gone on beforehand, typically, to prepare that data for analysis, to structure it, to get rid of outliers, to work out, is this the right data set to look at, and so on. And so I think things like machine learning and data warehousing and OLAP analysis and forecasting and so on, they're all going to be part of things going forward. And it's not some kind of old person's thing saying we'll always need cars and we'll always need wood and we'll always need kind of like, people to kind of shiny shoes and so on. This is not because we're being nostalgic, but saying there is more to analytics and more to data analysis than just one thing like machine learning, for example. Where it could get interesting is as vendors like, say, Amazon and whatever consumerize a lot of this and make it so that it's a service that is abstracted away. What I think will be gone is all the work involved in the kind of the infrastructure and all the work involved in some of the tasks that are so mind-blowingly kind of inane, like, say, going in there and just putting column names on incoming sort of files coming in, where you could easily just work that out from doing some classification routine on the data. There's a huge amounts of work that will go away that are just things that are just should be easily automated. But I think that there's a role for all different types of analysis going forward, and machine learning is one of those things. But it's not the kind of and having said that, we'll probably end up with Skynet tomorrow taking over the world and eating us all or whatever. But I think that there's more to it than just machine learning, really.
So the Apache projects, I mean, Hadoop was the earliest of the big data Apache projects, but now there's just like so many. I've done some shows recently on Apache Drill, Apache Arrow, Apache. There's one other, I think. But what are the Apache projects that excite you? I guess more broadly, what are the open source projects that seem exciting to you right now?
Interesting. So on the side there, we've got a running joke where we can just kind of mention some Apache project that doesn't exist and see whether the person still goes, I know that one quite well, actually. Yeah. So Drill and Arrow and projects like that are good. Drill particularly interests me because of the kind of so just to any listeners who've not heard about Drill before. So Drill is a project that is about SQL access to Hadoop data, but it's sort of, the key thing is that it gets the schema from the data itself. So, rather than with Hive, for example, you go and you have to kind of like define the schema and define the kind of the table structures and so on. Drill will look at the inbuilt metadata within, say, a Parquet file or an Avro file or whatever, and you can query it directly on that. And so that particularly interests me because it just, again, it changes the game in terms of how you do exploratory BI. We're trying to take away as much of this kind of ceremony and work that goes on before you can even get access to the data. Going things like defining data models and so on. And what Drill does is lets you just get to the data, start analyzing it and exploring it and really explore it in place. So you can connect to things like, a Hive kind of metastore. You can connect to a bunch of files. You can connect to Oracle, for example, and do stuff with that. And Arrow interested me as well. You mentioned Arrow a second ago because it's kind of, in a way, thinking about the in-memory kind of use of this and the in-memory structures and the way we pass data between each other and so on. So those things are interesting, but I think a slightly more kind of interesting take on that question is, as we now move more towards the cloud, I think we talk about which are the most interesting open source projects, but I don't talk about open source projects anymore because I tend to work in the cloud. And when you're working with, say, PubSub, or you're working with, which is like a version of Kafka, but it's designed for Google Cloud. When you're working with Cloud Data Flow, which is Apache Beam, which I suppose is an open source project. But as the more you get into these kind of services in the cloud for Hadoop, the less you're talking about the actual open source projects, the more you're talking about the services that are built off of them, really. And so I don't know. It's interesting to think about, in a way, will it be such a relevant conversation to have in a few years' time to talk about the open source projects that are going on, whereas actually we'd be talking about the services we get built off of those, really. Even Oracle, for example, are building in their Elastic Compute platform for Hadoop. They're building their own kind of transport services on top of Kafka, but they're not calling it Kafka, and they're just taking Kafka and putting wrappers around it. So I wonder really whether the ultimate irony of all this kind of stuff going on is that all of these kind of open source projects will effectively be the engineering department for Oracle and so on, not getting paid for it, and the way these things are all exposed out is as services they're charging money for. So that would be the ultimate irony of a lot of this work, really. And so going back to the Cloudeers of this world and Hortonworks, to make a big show out of saying we've got these open source projects, we just kind of give you a distribution. I can see that we'll be talking less about these things and more about the services that are provided by those big cloud vendors. And no one will be talking about open source anymore, which is interesting.
Okay, well, on that note, let's talk a little bit about Google and particularly BigQuery, just to wrap things up, because you wrote an article about BigQuery recently. I'll link to that in the show notes. So when I look at BigQuery, I really get the feeling that they are, I guess I already said this, they're doing the same thing that they're doing with these other systems like TensorFlow and Kubernetes, where they're making a managed version of, making a really high-level managed version that's really easy to work with, which, as you just mentioned, is probably what we're going to be increasingly using as time goes on. And I think that's great, because I think developers get a lot more leverage from that point of view, like just utilizing as many cloud resources as you can, these high-level APIs that are getting cheaper by the minute. So I guess explain to people what BigQuery is and what it is symbolic of for Google's bigger strategy of the cloud.
Okay, well, it's hard to say what Google's bigger strategy is, but certainly, but it's never stopped you having an opinion in the past. So I'll speculate on that. So first of all, BigQuery. So BigQuery is, I think, to take the definition of it, it's a cloud native column store distributed compute and query engine. So obviously Google were the ones that came up with, Bigtable, and which came into sort of MapReduce and so on as time went by. This is very different in that you load data into BigQuery. It goes in the form of tables. So it's similar to things like Kudu, for example, where from the Apache project, where, again, you load into these tabular sort of stores. You typically load in a very denormalized form. So instead of having dimension tables and fact tables and joins and that sort of thing, you typically load it in a denormalized form, and that has quite an impact on how we do analytics and joins and so on. It's columnar. So when you query it, you only retrieve the columns that project the columns you're interested in. It's in memory it's in memory, I think, as well. And it's really fast. So to query, a petabyte of data is as quick as querying, a gigabyte and this sort of thing. I think the interesting effects on it is that you don't think about data modeling time. So you don't go in there and carefully define, you might define things as being string or integer or whatever, but beyond that, it's kind of not there. You just load in and go as it is. It's typically append only. I mean, you can absolutely update things and so on, but it just, in a way, it removes so much of the tasks in data warehousing that you used to think were just essential and things you just had to always do. Things like data modeling, instance tuning, all that sort of thing. There's no indexes. So, you think about all the work that goes into indexing and rebuilding indexes and bitmap indexes and kind of, B-tree indexes and that sort of thing. That's all kind of gone. So it's just really fast, and there's still a need, to my mind, to do things like pre-computing aggregates. How you do joins when you do need to do them is interesting. But it's so much of what we used to spend so much time on before is now no longer a task you to think about. And in terms of Google's kind of strategy, I don't know. It's interesting. I mean, what their strategy is around big data analytics on the Google platform is kind of not quite as clear as it would be with, say, Amazon, for example. There aren't really, I mean, just to be in full disclosure, I kind of know a few people in there, and I've spoken at some points in the past about joining their team in this kind of area. But I'm not entirely sure what the strategy is taking these things forward, apart from to say, here is technology we've developed internally at Google. We think it'll be interesting for other people to use. There you go. There's the instructions. If it's not what you want, well, good luck. Go somewhere else. But if it is, then if you build things in the same way that we build them at Google, then you'll do really well. And so that's the strategy as far as I can see it, really.
Okay, Mark. Well, I think we made it through a pretty decent chronology of data warehousing and particularly moving towards the cloud. I want to thank you for coming on Software Engineering Daily, and anybody who is interested in topics similar to what we have covered, I recommend the Drill to Detail podcast. I enjoyed listening to it to prepare for the show, and I subscribe to it. So thanks for coming on, Mark.
Thanks, Jeff. Thanks a lot. Good to speak to you.
Software Engineering Daily uses Imperva Encapsula to speed up requests and protect our site from botnets and other unwanted traffic. To try Encapsula, go to encapsula.com/sedaily and get a month free for Software Engineering Daily listeners. Encapsula's API gives you control over the security and performance of your application, whether you have a complex microservices architecture or a WordPress site, like Software Engineering Daily. To try Encapsula today, go to encapsula.com/sedaily and check it out. Thanks again, Encapsula.